Hello. All right. It's a big screen. Thank you for being here and listening to me rant about hardware stuff. I'm not a Java developer, so confession, but I'm more on the iOS side of things. But I do like hardware prototyping. It's something that I've been playing with as a hobby and more recently as part of my work for the last 5 years. And I'm going to talk about a little bit about my story, how I got into it. I don't have any previous electronics experience, any hardware experience, so I came to it from a very software perspective, and I hope that will inspire you and seem interesting. So by day, I work at a company called Hippo. We're a product consultancy company. We work with startups to build software products. So we're very much software-oriented, finding solutions to product problems with software. That's mainly what we do. And by night, I usually have no idea what I'm doing dealing with hardware stuff. So as I said, I'm not an expert at electronics. I don't have any formal education, so take whatever I say with a grain of salt. But I did do some interesting projects, so I hope that will show you that you can find your way through trial and error in this crazy world of hardware. And that's kind of the point, that other people can also get into it. If I can do it, you can definitely do it. So I really like this photo because it perfectly illustrates my impression of the hardware world before I got into it, right? I mean, it's scary, inaccessible, and weird, and it's a complete nightmare for an OCD software developer like myself. I think this was definitely true, maybe 10, maybe 15 years ago even, and it was very inaccessible. But in 2005, this little guy got introduced to the market in Italy. It was a research project. And Arduino basically transformed the hardware hobbyist market for the better. And the idea it was to provide a prototyping tool for artists, for hobbyists, to be able to get into electronics, to be able to teach electronics, and it's completely transformed the market. So thanks to this, it's now much easier to do stuff in the hardware world. So today, Arduino is not the only option. There are lots of different platforms available and lots of different options. And also that brings a level of confusion, I think, because people talk about certain platforms as if they were equal, which they're not. And people talk about hardware prototyping as if you could do it on any platform. So I'm going to start with that and give you a high-level overview of what's out there. Probably one of the most well-known options today is Raspberry Pi, and it's definitely an amazing platform, and you can do a lot with it. And it seems like a great entry point for most people to get into hardware, because it's basically a complete Linux PC with hardware I/O ports, and that's great. And it's very powerful, but it's definitely not a prototyping platform, because this is already a miniaturized PC. So you can't really miniaturize it further. So you can't really bring, if you develop something on this and it's working well, you're not really going to be able to take that to a hardware engineer and say, well, let's manufacture this. It's going to be impossible. So they're going to have to redo that whole prototyping work again. So it's not really something you can iterate on. And also, running Linux and then being able to, talk with hardware I/O ports is great, like being able to write a Python script, for instance, and just talk to, different devices and sensors. That's awesome. But it's really not hardware is done, because there are issues, for instance, with garbage collection. There are issues with a lot of other things that you wouldn't have on a real IoT platform like Arduino. So just beware, it's totally okay to use Raspberry Pi to do hardware projects, but it's not really how I would recommend someone get into it if you really want to do hardware stuff. Another one is BeagleBone, very similar, even much more powerful miniaturized PC. And it's great as a small computer, but it's not really something that you can use for something like what Arduino can do. And it's also very limited in terms of additional modules that you can use. A better comparison point is something like the Tessel. It's great for an introductory, foray into hardware. It's a modularized JavaScript hardware platform, so it runs JavaScript. You can write JavaScript firmware on it. That's pretty awesome. It makes it easy for a lot of people to get into it. But it's turned into a very simplified product. So you can't just buy some modules on Adafruit or SparkFun and just integrate them into Tesla. It's really hard, and in some cases even impossible, because they have their own modules that they sell, so you're very limited by your options and what you can do with it. So that brings us to Arduino. So why is it so powerful? Well, first of all, it's an open source and very simple device. So it's really built on this microprocessor, and it's really an exploded, so instead of miniaturized, it's an exploded version of a very simple hardware board, electronics board. So at the heart of the Arduino, there's this AVR chip. It's an Atmel Atmega models. Different models have different chips. And it's all open source hardware, so you could actually buy this chip separately and build your own Arduino if you wanted to. And all the schematics are up on the Arduino website, and it's actually pretty easy to do. I've done one myself, and it's not that hard to do. They really explained very, very carefully. But you don't have to do that. You could just buy it very cheaply, but with the understanding that this is like an exploded, expanded version of a really small device. So it just gives you the option to easily plug in things and then start prototyping. That's the whole idea. In terms of firmware, it runs C or C++. So they don't have the greatest IDE, but there are lots of options out there for using Eclipse, for using other like Sublime Text, even simpler editors to be able to run firmware on it or write firmware for it. The compiler is fairly simple. So from a software developer's perspective, it's a very limited platform. But the nice thing is, and this is something that will be recurring in my talk, is I don't think we should be thinking about the software that we can run on this thing. I think we should be thinking what we can do with it, and then how we can work on platforms that we already know about, and how we integrate with those. There are a few different models of the Arduino. This is the Mega. It's very similar to the Uno that I showed. It has more I/O pins, a bit more memory, more processing power. So it's better for some more complex projects. But overall, it's very similar. Whereas a new addition to the Arduino models, Yun, is actually a competitor to something like Raspberry, for instance, because it actually has a miniaturized computer inside. So there's a separate Intel processor inside that runs the Yun unit. So it comes with integrated Wi-Fi and all these things, all these bells and whistles. But again, you can't really use this for prototyping. So just something to be aware of. There are all these different Arduino models, but really, if you're looking to do actual IoT work or something similar, then you got to go with the Mega or the Uno at the moment, at least. And there are other options available. Like there's like FreeDuino, for instance, an Arduino clone. There's Tiny Duino, like really miniaturized version of the Arduino. So there are all these different options that you can always look at. So how do you get into it? When you search for intro to Arduino tutorial or whatever on Google, this is usually what comes up, right? Classic intro project. It's an LED blink project. You just blink the LED. It's super boring. It's completely pointless. And I really don't know why people do this. But so if you come from a hardware background and you don't know much about software, this actually makes sense, because you already know your resistors, you know how an LED works, you know how the Arduino works, so you just attach them, and then you kind of go, and the software side of this is really simple. So you just, within the loop, you just call the LED. So if you're getting into the software part of things, into writing firmware, for instance, it's a good starting point. But for us, it's ridiculous, because we handle the software part in 5 seconds, and then you deal with how to attach this thing, how to you try to understand how ground works, and what kind of voltage you should choose, and what kind of resistor you should add. And every step of the way, they warn you. You could fry your board, and if you do something wrong, it's going to burn and like cause a fire or something. So it's really scary from a software perspective, software developer's perspective. So I suggest you don't do this. I don't think it's a good idea. I don't think it's a good starting point. For software people, I suggest starting with sensors. They're great, they're cheap, they're abundant. You can buy, temperature sensors, humidity sensors, carbon dioxide sensors, like all kinds of sensors are out there available on various sites. And they're really plug and play. They come with their own little software libraries that are super simple that you can read the source code for. But in terms of attaching the hardware, it's super simple. You just attach it. You don't have to think about resistors or anything. And now the nice thing is these are really complex from a software perspective, because now you have to write the firmware that talks to this thing. Even though there's a library, you still have to think about how to get that amount of data from the sensor, how often do you poll, what do you do with that data, how do you display it. These are the more interesting questions from a software perspective. So I really recommend you start with something like a humidity sensor or a temperature sensor, for instance. They're tiny. This is one from Adafruit, I believe. And you attach that to a breadboard. This is what you use for not having to solder every connection, every pin that you have to use. And I know that soldering is something that people are really scared about as well, but it's really simple, and you can get away with not doing it for probably months or years. Like I didn't learn how to solder until I was 2 years into hardware stuff. So you really don't have to know it at the beginning. And even when you do learn, it's actually really simple to do. So it's not a huge deal. And you need lots of these. You will use a lot of pins and cables during prototyping. So, an example project, you hook up a temperature sensor to an Arduino, and then you have this LCD module that you buy, and it's easy to hook up. It has a lot of connections, but it's super simple. And then all the rest is software. So once you're done with the hardware prototype, you just jump into the compiler and start writing something. And even with something as simple as this, you can do a lot. Like you could, for instance, think about how on such a limited display, how do you display the data? You have to think about the UX. You have to think about, do I add like a motion sensor to this as well? So when I come by, the LCD comes alive and I can see. And then after a while, I turn it off. So you can really iterate on this, and it's a great way to challenge yourself. It's a great way to think about these limited hardware systems and to understand their complexities and limitations. This is, for instance, one of my first projects that I did. It's again, basic humidity sensor or something like that. I paired it with an iPhone app. So easy to build hardware, and then I had to deal with the complexity on the iPhone side, where I knew what I was doing. I paired this with a Bluetooth LE module, which I will talk about later. And this was a sample app that, once connected, it could display live data on the screen and it could graph it. And of course, this is a very, simple and horrible interface, but then I could iterate on this and make something much more interesting. And the nice thing is you get abundance of data with sensors. So that's what we love, right? You have all that data. Now what you do with it is totally up to you. A better example was something that we built at the office. It's basically our office or home monitor with multiple sensors on it. It worked on Wi-Fi. It was very challenging from a network programming perspective, because you have to deal with stuff like what happens when there's a problem with the connection. What happens? How do we send this data to the server side, and how do we graph it? How do we visualize it? So suddenly you have, from a very simple device, you have all these software problems that arise, and those are the real challenges. So I'll keep talking about my projects for a little bit before jumping into other stuff. So at my company, at Hippo, we have these hack days every month. One day, usually hardware hacks. Everybody drops what they're doing and approach, something, a hobby project from a software perspective, and try to solve a problem. You have to present the project at the end of the day, so it can only take one day. So you have to, know your scope, know what you can accomplish, and some interesting stuff came out of that. So I'll talk about that a little bit. So we love giving IKEA-like names to our internal projects. This is Dur. It's basically an app-driven door buzzer. So we have this buzzer for the entrance to our office. And the problem was we would all go out to lunch, like 12 guys, 2 girls, and we wouldn't be able to get back into the office because everybody would have left their keys. That actually happened. So we thought, okay, we can solve this with software and hardware. We can find a solution to this. So we started with a simple Arduino device, the Arduino Uno. We got one. And we attached a relay to it. Now, a relay is a very simple module that allows you to control a 240 or 110 volt circuit with a 5 volt signal. So it's basically an electronic driven, light switch. You can think of it like that. So once you attach this to the buzzer, you have electronic control of the buzzer. What you did with the actual switch before, you could do through the Arduino. To that, we attached a BLE module, a Bluetooth LE module. Now, Bluetooth LE is a kind of the next generation of Bluetooth. It's been around for a few years now, and it's pretty much available in every mobile device, in most Macs. I think iPhone 4S and newer have the module in it. So it's not really Bluetooth because you don't need to pair the devices. So you can just, once you see the device, you can connect to it and send signals to it. So if you know how to talk to the device, it's almost instant communication, and it's very low range, but it's very fast, very low latency. So once we had the BLE device, now the Arduino became a wireless receiver of messages. And then we could implement a simple Android and iOS app and just send a message to the BLE. The BLE sends it over to the Arduino firmware, which just takes it and says, okay, I'm going to open the door. And it decides to deactivate the relay based on the request. So this was the basic prototype. This was ready at the end of the day. This is less than a day project that you can do with Arduino. But we've been using it every day since then. It's super useful and really nice to have, and it's a really fun project to work on. We decided to iterate on this a little bit. So we thought, okay, wouldn't it be nice if we show the app icon on the lock screen when you come to the office, so you don't have to search for the app to open the door. So we used an iBeacon. There are lots of iBeacons available now. Apple provides this thing on iOS where you can actually pop the app icon up on the lock screen when it registers the iBeacon signal. So we added that. That made it a little bit easier. And then, of course, we had to do an Apple Watch app. So we did that. Why not? And funny enough, the Apple Watch app is the one that everyone uses now because it doesn't even need the iPhone. Because Apple Watch has BLE as well, it can talk directly to the Arduino device. So you have direct communication. Even if you don't have your iPhone, you could use it. I'll actually show you a video of this because it's interesting. So it makes more sense when you're outside, but we had to shoot it inside. I know you caught that, but yeah. And then someone added that Mario theme because they couldn't resist it, and now every time we enter the office, we have to listen to that, but it's cool. So that's one, and I mean, you can see it's very iterative. Of course, not all of this happened in a day, but overall, this was like a 2 or 2.5 day project that everybody collaborated on, and it was really interesting to see it come together. It's a mishmash of different technologies and different things available, and but at the core of it is the Arduino, and I think that's what really makes it so easy to iterate on, because you don't have to think about a lot of other complex things. These platforms are ready to go for you. You just kind of plug and play, and then deal with the complexity on the software side where you actually know what you're doing. Another one is Bulb. So this is a light control system, obviously. It's very similar to the first one, to Door, but the challenge with this one was we wanted it to work remotely, and The problem was, being able to see which lights were on at the office, because we have a few different floors. When you're leaving the office, it was a bit of a chore to, figure out which floor to go to and like close things. So we want to work remotely, so we could, check if the lights were on at the office for some reason, or turn them on or turn them off, or like schedule lights turning on and off. Now, of course, could we, buy an existing solution for this? Of course we could. We know we can, but it's an interesting challenge for software developers to jump into a problem like this, because you can really over-engineer this, and some people suggested that we should, or you could approach it very simply, like we did here. So it really depends on what kind of problems you're trying to solve. You could have like a internal server that runs at the office, and then a remote one, and then the internal server kind of controls these sub-machines that are more simple IoT devices. Or you could have every IoT device just connect to the internet and like register for a service and just listen for certain messages. So that's what we end up doing, just because we didn't want to blow the scope too much. But so again, we started with a few Arduino Unos, one for each floor. And again, we had a relay because we need to control multiple lights. So for every light bulb that you need to connect, you need another relay. And but then we had this, in some cases Ethernet, in some cases Wi-Fi shield that we attached to the Arduino. So in case you don't know what a shield is, it's basically a module that's the same size as the Arduino that just connects on top. So it takes control of some of the pins of the Arduino, and then it still allows you to connect more if you need to. So it's like, again, an exploded version of a small device. In this case, we have a Wi-Fi shield that just connects on top. So you have the Arduino connecting to the internet, to the office Wi-Fi through this connection. And now, once you have the Arduino connected, how do you know which ones are available, and how do you send messages to it? Obviously, you don't want to expose, certain IPs from the office network and all that stuff. So there's a lot of complexity that comes into that infrastructure. So we decided to use a service called Pusher. They are basically a pub/sub service that allows real-time messaging to IoT devices, they say, but it could be any device really, or it could be any service. The idea is the Arduino devices, in this case, register for notifications from specific channels at the Pusher service. And so whenever they're online, they're ready to receive those messages. And then your app or your service basically sends a signal to Pusher saying, on this channel, send this message. And all the devices that are listening to that channel are automatically notified immediately. And Arduino parses that message, makes a decision, activates or deactivates the relay, turning on or off the light bulbs. Now, this is much more complex than the previous one, because you don't have to be in the same room with the device. You can control remotely, and also, again, Wi-Fi connectivity, especially network connectivity in general, is very fickle. I mean, anything could happen. You could drop some packets, or you could just drop off the Wi-Fi network, and you have to, because Arduino is so limited in terms of its software capabilities, you have to deal with these things and be able to continuously test the service to make sure that, because these things happen over time. So some bugs came up a week later, we started using this, and other bugs came up a few months later. So it's important to battle test, and it's important to think about how to defensively code a firmware that runs on on the device. So again, I have a little video just so you see how it runs on our test bed.
Hey Iris, turn on all lights. Hey Iris, turn off all lights. Hey Iris, turn lights on at first floor. Hey Iris, turn lights on at second floor.
So we later on added this little voice recognition module to the iOS app, but you get the idea. Basically, And because Siri is not available, we call it Iris, of course. We can resist. But so the idea is, you send a message, the iPhone app makes a decision on what you want to do, turns that message into something that the pusher will understand, sends it over, and then the Wi-Fi connected device basically parses it again and then makes the decision. So fairly simple usage, and that's great because it means that for the user, this is a very simple thing to do. But behind the scenes, you can see all the things that are happening and all the iteration that needs to happen. So it's really interesting and it's very challenging from a software perspective. That's what I like about it. So those are some of the office projects. I've also been dealing with simple robotics. Well, I don't know if you can even call it robotics, but anyway, like simple robots, right? And what I was interested in was not really the mechanical part of it, because that's really beyond what I can spend time on, but more the complexity again in stuff like, for instance, pathfinding and intelligence, and how do you write software for something like this, where the hardware is super simple and super limited, but the software can drive it in a way that is like somehow intelligent, or can you do it? So, I've been dealing with this kind of stuff for a few years now, and this is one of the first, I think this is the first one that I developed, and, it just uses this acoustic sensor that tries to figure out the distance from the next object in front of it, and it has a little servo underneath, so it can like turn its head a little bit. And it's driven by an Arduino again, and of course in this case you have to think about things like battery and power, and I will talk about those things a little bit down in the presentation. But there's a lot more complexity involved from that point. But really, once you build it and the motors are running, there isn't much to the hardware. I mean, it's maybe a weekend project. But after that, now you have the ability to burn different kinds of firmware on this and see how it reacts. So, you let this go, on the room and just like walks around and you see how it reacts to certain things. Then you just manipulate the software and test again and iterate and see how it reacts to, to the things in front of it. How does it find its way? Does it just completely go berserk and like try turning around in circles, or does it actually able to find its way around the room? And I really like this idea because this doesn't depend on anything else. So it's very self-contained. So this was my first foray. And the problem that you run into with something like this is, for instance, the noise in the data. So you get data, but you don't know if you can really rely on it. So how do you normalize that? Again, a software problem. How do you visualize that? Again, a software problem. So those are the great things about this. Another robot that we built at the office is this is actually much simpler from a control perspective, because it's a remote controlled Bluetooth LE robot. So you just control it from the iPhone app. But what was interesting about this was I decided to use the accelerometer in the iPhone to make the robot look around. So that was really interesting to see, because it showed the capabilities of the BLE protocol. It was super fast, so you could really drive this thing remotely and just like look around. And we had this video stream running from this little iPod Touch attached to it, so you could actually see what the robot saw. So it was really interesting to play with. I have a video of that too, because it's just fun to see. So you get the idea. Again, a very simple project, but using it was really interesting because the effect was so instant. You could really feel like you were in control of this thing, and you didn't have to be in the same room. It could, you could have it go to the next room and like walk around the office, and so it was an interesting challenge from that perspective. And the last robot project I'll talk about is one that's actually in progress. So there's this technology called LiDAR, and there was a Kickstarter project for a LiDAR module, a cheap LiDAR module, recently, last year. And so, I got one of those, and it's really interesting because LiDARs are basically, they're laser-driven, distance measurement units, and the really expensive big ones are used in, for like 3D mapping whole terrains or 3D mapping buildings. The Google car uses one on top of it. So the, $3,000-$4,000 ones are super capable. But this little one, it's literally like this big, and it costs $60. Is really interesting because you could still get some data out of that, and it was quite capable. I built this little robot that was super simple, and I just wanted to act like literally like a dumb client to a Mac application. So the Mac app would run the robot, just gather data from the LiDAR unit and say, okay, now go here. Well, it can't even say go here because there's obviously no Google Maps for this thing. So it needs to say go, forward this many circulations on the motor, and then go turn right and go this much. And by doing that, try to map an environment and see if we can visualize the incoming data. Now, again, this was really interesting because I could write a Mac app that did this, and I didn't have to really do much with the hardware after that. So, I just recompile the Mac app and see how it reacts, and recompile and iterate. So it was really interesting from that perspective. The latest version kind of looks like this. So it's similar to this, but again, there's a lot of noise, a lot of stuff you have to deal with, and how do you turn this into an actionable map? Where the idea is you can click on and then use pathfinding intelligence to go there. But again, you can see, going through these different marks of robots, you can see how you can iterate and like go forward and find the next challenge and do some really interesting stuff. So those are more or less all the projects I'll talk about. I think it's really inspiring to talk about other people's projects because it kind of gives me other ideas. So I hope that's interesting. But another way for me to get inspired is to just talk about the modules and the sensors that are available out there. And it's also really because there's so much choice, and it's kind of endless world of different electronic devices with obscure names. It can be really hard if you're just getting into this world. So I'll talk about those a little bit. And as you've seen from these examples, probably the most interesting thing is the communication part, because without that, the Arduino is just like this isolated thing on its own, and you can't really do much with it because of the limitations on the firmware and the actual hardware memory and processing power. So let's talk about communication options. This is the one that we used in that bulb project. It's called this Adafruit's CC3000 Wi-Fi shield. So it just connects you to the Wi-Fi. Super easy to set up because it's a shield. You just connect it, you're done. And don't be surprised by the size. It's actually, the actual size is this. So this is what they call the breakout module. So it's the exact same module, but it's in breakout format. So you could either buy this, which is the miniaturized version, or you could buy this one. So in any case, depends on how you want to use it, but it's not as big and complex as it looks. Now this comes with its own Wi-Fi library, which is fairly capable. It's not bad at all, and there are some competing libraries as well that you can find open source available. So it's great if you just want to connect to a server, either via TCP stream, or you can even do HTTP requests, and you can upload images. You can do all these things fairly easily. That's probably the easiest way to get into some kind of communication with the Arduino. Another one that I've been using in a lot of projects is the Bluetooth LE module. So as I mentioned, it's a progression of the Bluetooth, but it's not really Bluetooth because you don't need to do pairing. So it's very impressive, it's fast, and the only downside really is the bandwidth. So you can't really, for instance, over Bluetooth LE, you can't really transfer images, for instance, or any kind of large amounts of data. It's just too slow for that. But for sending small signals or small amounts of data, it's very impressive. And both on iOS and Android, there are very robust libraries for integrating with Bluetooth LE modules, so it's great. XBee is an interesting communications platform. It's probably the oldest, so this has been used by people who are, building drones or any kind of remote control device for years now. They're basically paired modules, so you just pair two XBees, and they literally just replace the USB cable that you attach to your Arduino. So you could, build everything with a USB cable, take it out, put in two XBees, you're done. You don't need to do any software. It doesn't need a library. It just communicates over the serial communication port from the Arduino. So it's a great tool, and there's a huge variety of XBee modules. So there are really cheap ones that are fairly low bandwidth and low range, and they're really industry scale, fast, high bandwidth, and very high range versions. SparkFun has a great wiki page on the different XBee modules comparing them. So if you're interested in getting these, it's a good idea to check that out. A few new ones. So there are some newcomers to this area because I think there's going to be a lot more advancements in this area in the next few years. So this is Nordic Semiconductor's, well, the name is NRF24L01. So it doesn't really have a name. But it's basically, Nordic does these really impressive communication modules. This is a 2.4 gigahertz thing that has a bandwidth of 2 megabits and 100 meters of range. So it's this cheap module that you can buy. It's a bit hard to integrate, but it gives you both bandwidth and range, and it's really impressive. And you can integrate this with an Arduino and have a robot that runs quite far away from the actual device. Another one that recently came out, and this, if you do some research, you will definitely run into this, is this $5 Wi-Fi unit. It's called ESP, and there are different numbers like ESP 8266, ESP something something. Super low power, direct connection to Wi-Fi, and super cheap. And it's really amazing. And it also comes with its own microcontroller. So you could actually use this without an Arduino. So you could just buy this thing, attach it to a sensor, and write firmware for it that understands what the sensor does, and just deliver that data over to a cloud server or to whatever. So very impressive. Like you could buy a ton of these, put them around this room, and then monitor certain amounts of data really easily and cheaply. So it's very interesting to see stuff like this coming out. So relays I talked about. Moving on from the communication stuff, there are some other interesting modules that we can talk about. So relays allow you to control lights, switch electrical appliances. Really simple to integrate. They run on 5 volts and then can control anything on a higher voltage. So they're great for home and office automation. If you want to do any kind of robotic stuff, this is a motor shield, and it can drive 2 DC motors independently. Now, the motor shields are really necessary for driving any kind of motor, because you can't really run the motors on the Arduino power, because the motors require quite a high voltage of power. So these shields allow you to isolate those power sources. So the motors can run on a separate battery pack, and then your Arduino can run on a different one. And driving motors is actually surprisingly a complex thing to do. You would think that's something simple like this, which I used to play with when I was a kid. I used to rip out the motors from my toys and for some reason play with them. But apparently driving them in a sensible way requires a complex architecture. And even then you will run into power issues. And really, for myself at least, the problem that I ran into most when building robots was the battery issues, and how much voltage do you need, and how do you use it intelligently. It's a big problem, and there isn't a lot of information on it out there yet, at least. There's some interesting screens and UI stuff that you can buy. This is an OLED display. It's really small, it's tiny, but there are bigger versions of this. One thing that you could do for this, for instance, is actually make a face for your robot, for instance. Like it could like move around and show a smiley face or a sad face. It's really cute. And because it's OLED, it's super low power usage, so it's really interesting. This is the LiDAR that I talked about earlier. This was a Kickstarter project, but now it's available. Super affordable, easy to integrate. Again, the problem becomes how do you use the data that comes from this thing. This is a GPS module. It's fairly cheap. I think this is on SparkFun. Super small. It can connect to like 60-something satellites, and it actually has standalone tracking capabilities inside, so it can log the locations inside, and you can retrieve them later. So again, so many options out there, and every one of these modules could be the reason for a new project, for something that you could play with or iterate on. That I was thinking of, for instance, I bought one of these GPS modules, and I always want to build like a standalone tracking for runs. So whenever you're doing a run, you could have a separate device that actually recorded high resolution info on the run. It could be really interesting. So lots of options out there. Now, the last thing I want to talk about modules is I used to be really afraid of small components that you could buy. So this is an EEPROM, I believe. It's a 128 kilobyte memory bank, right? So this is literally something that you attach on the breadboard, and then you attach the right pins, and then you can stream data to it and then stream data back. So it acts like a Redis cache that's physically available on the breadboard. It's really interesting, and there are versions of this that can actually store the memory inside, and then versions that actually erase the memory like a RAM once the power is out. This is actually super easy to integrate. I was working on a video camera, really a baby camera project for my daughter, because I want to build my own baby cam. And it was, of course, a folly because it's very complex to do. But I underestimated the amount of data that the VGA camera, the simple VGA camera, would deliver every second. And no Arduino device is capable of delivering, streaming that kind of data. It's just there's no memory available, so you can't really buffer that information anywhere. So after much research and a lot of pain, I came to the realization that I had to build my own memory bank, because you can't really do this on a simple device like the Arduino. Now, if you just want to skip to the conclusion and find a solution, you could, of course, use like a Raspberry Pi. But that wasn't the point. The point was, how do you transfer video information on a simple IoT device to a remote server or to a remote device, hopefully wirelessly. I bought a few of these. They're like 30 cents each or something. It's ridiculous. And they arrived in this like little capsule and this little tube, and they're super tiny. They're like just as big as my nail or something like that. And they look really scary, but then you read the schematics, you need just like a few pins, you attach them next to each other, and then that's it. The rest is just software. You just find your memory bank, write to it, and it's as simple as splitting strings and just writing them to the right place and then reading them in the right order. For me at least, the lesson from that was, don't be afraid to buy small components. They're not that hard to deal with, and they can actually really augment the capabilities. Because if you wanted to take something like this and actually manufacture it, because you use these components that they would actually use in manufacturing, you're going to be able to say, well, yeah, let's just use this component and design a board that just works in the same way that I prototyped, and you can actually manufacture that right away. So it's pretty impressive. So beyond modules, I have a few shortcuts that I want to talk about, because especially when dealing with mechanical stuff like robotics, you have unexpected complexities that arise, and these are not usually from the actual electronics, but like you would prototype this thing and it would be a mess on the table, and then you somehow have to enclose it or put it together in a way that makes sense because you can't even carry it around. And how do you solve those? Now, the very obvious solution that comes to mind is a 3D printer, but they're slow and expensive, and they're not really there yet, in my opinion. So it's very cool, but you really don't have to go out there to buy a 3D printer or even use a 3D printing service, because there are lots of other shortcuts available that you can use. My favorite is Toys R Us. It's the best place to find dumb robots. So you don't really need to buy one of the robot building kits that are like really expensive. A simple robot kit is like $200. You could go to Toys R Us and buy like a toy that looks the same for $10. So, you can buy cheap, dumb toys and add intelligence. It's a lot of fun, actually. Another one that's my favorite as a tool is the Dremel. I think they're also available in Europe. They're available everywhere. They're basically, you can do anything with a Dremel. It's like a drill with different tips. So you can, cut into plastics, even metal. You can polish things. You can, drill holes. It's super useful if you're doing any kind of enclosure design, or even just, putting things into and like attaching them to a box. And, I love using like old, sturdy, modems or stuff like that. You can just take them apart and just use the enclosures, because they're really strong, and they're really sturdy, and you can fit a lot. So they're really useful. And of course, glue guns or double-sided tape is your best friends. Now, I want to talk about the software side of things a little bit, because integration with these devices is super easy. Serial communication is the easiest thing. On Mac, for instance, there are two commands. It's it's just read and write. They're literally just called read and write. You just open a TCP stream. You just open a socket from the USB port, and then you just read and write. That's it. There's no other super library or SDK available. So you have to really be disciplined in terms of your communication, because it's so open-ended. You can really go crazy, building crazy protocols and doing lots of things. But it's easy to fall into that trap. So for software, a few rules I have is, first of all, keep the firmware as dumb as possible, because the firmware is very limited. The device is very limited. The language is very limited. And the amount of stuff that you can do on the Arduino is going to be limited by its performance, by its battery power, by its memory. So treat the hardware like a mobile application. It's basically a dumb client that just gathers data or does something, and then just gives it back to your much more intelligent server or much more intelligent iPhone application, and do as much as possible over there. So logging can be something of an afterthought on a device like the Arduino, but it's easy to do. You could buy a simple memory module. You could buy, for instance, the Wi-Fi module that I showed you comes with an SD card slot, so you could actually use that slot to write to an SD card. So it's actually really easy to have like a log file that just keeps track of what happened. So think of it like a web server log. And this comes in really handy when you battle test it. So when you take this device, let's say you have the simplest home monitor device. You just put it out there, you forget it for a month, and then you just monitor it and see what happened. And if it stops working, you go there and you check the logs. As I mentioned earlier, if you have a Wi-Fi connected device, you are going to have issues where the connection just hangs. And these devices, these libraries are not clever enough to say, well, my connection is hanging, so I'm going to time out. It actually doesn't time out. It just stays there. So you have to deal with those things, and you have to understand that you might have to, have the device reset itself in some cases. And it's not that easy to do. So, you have to really defensively code the firmware in a way that handles those situations. And the best way to do that is to just test it in an environment where it just runs over a long time. And, design simple but versatile protocols. So, for instance, this is an approach that I sometimes take. Instead of sending certain messages to the Arduino and saying, you should understand this, because the Arduino's, encoding and decoding capabilities are pretty much non-existent, you could just say, I want you to turn on this pin, like this hardware I/O pin on this port. So instead of saying it stuff that it should parse, you could just tell it stuff that it would just understand without having to parse it. So that's one approach that you could take. So that way, you don't have to really burn new firmware into the Arduino every time you add a new feature, or every time you have to change something or you find a bug, because all the complexities on the software side, the Arduino is just taking that info and saying, okay, I just say on or off to this pin, and it doesn't really care about the meaning of it. So yeah, just beware of that idea of like low bandwidth, low memory, low processor power. So the last thing I want to talk about is open source, because it pretty much doesn't exist in the hardware world. As I mentioned, the world of hobbyist hardware or hobbyist electronics is a world of hardware people mostly still, and it's changing. But this also comes with the side effect that you get a lot of these hardware tutorials on how to connect things, but there is no real good open source software out there that you can use. So my approach to this was, let me do all these projects, and I'm just going to put everything up on GitHub, and hopefully other people will use it. And I was thinking, who's going to use my stupid robot code, because it's just a hack. But to my surprise, for instance, last year I received this email, and it pretty much made my year. Jared here is a special education caregiver in the US, and he actually used the code we open sourced for one of the robots in autism therapy for kids. So they actually built this robot, and it was teaching kids how to empathize with other objects, and they found that it was a really effective way. So he wanted to turn it into a robot that he could remote control, because it was easier when there was no other adults around. And but they couldn't find a way to control it. And then he was searching on the web, and he found my repo, and he just used it because it was ready and available, and it was ready to use, and they were done. And then he sent me a thank you note. And I think this is why it's so important to share your work, even if you think it's not good enough, because other people will find a way to make it useful. And hardware community really needs software people, even if they're hobbyists, even if they don't know what they're doing, to share their work and to talk about it. And robotics are, I think, a great tool for teaching, just in general, not just electronics, but teaching art, and teaching small kids how to get into software. So because you can actually physically see the results of your work, so it's very interesting in that sense. So I still have no idea what I'm doing, but it's okay. You learn by trial and error, and so I'm pretty confident if I can do it, anyone can do it. And I hope this inspires a few of you to get into it. Everything that I talked about today is open source, available on GitHub on these repos. If you want to reach me, I love talking shop about hardware, so email me, ping me on Twitter. I would love it. And yeah, I hope you enjoyed it. Thank you.